Welcome to The Explainer. Today, we're diving into an absolute masterclass on how to drastically improve the way we communicate. We're going to learn exactly how to strip away visual noise, reduce cognitive overload, and completely transform how people actually process your ideas.
Okay, let's dive into this. Have you ever been sitting in a presentation and literally within the first 3 minutes, you completely tune out because the slides are just this massive, impenetrable wall of text? Yeah. It's a universally relatable problem. We've all been there as an audience. And look, if we're being totally honest with ourselves, we've probably all been guilty of creating those exact same slides too.
To fix this, we need a clear roadmap. Today we're covering the cognitive overload problem, the power of dual coding, the zero redundancy rule, Gestalt principles, simplifying software architecture, and finally, an active visual critique. And just giving you this clear structure right up front actually reduces your cognitive load immediately.
So let's jump right into Section 1, the cognitive overload problem.
To really understand why bad slides fail, we've got to look at the biological limits of the human brain. Cognitive load theory is this instructional design framework that explains exactly how our brains process new information. And the massive biological bottleneck here? It's our working memory. Research shows working memory can only hold about 4 chunks of information at a time before it just starts dropping things. So treating your audience's attention as this scarce, highly limited resource is absolutely crucial.
And that brings us to the fundamental battle in all presentation design: extraneous load versus germane load. Think of extraneous load as mental effort wasted on bad distractions. Messy layouts or completely irrelevant details. Germane load, on the other hand, is the good stuff. It's the beneficial mental work your brain uses to build schemas for long-term memory. Our goal is always to minimize the bad extraneous distractions so the brain actually has room for that good schema-building germane effort.
All right, moving on to Section 2, the power of dual coding.
So, how do we hack those strict memory limits? Well, we use a 2-channel approach based on dual coding theory, which Alan Pavio developed way back in 1971. He proved that the brain uses 2 linked paths, a verbal system and a nonverbal imagistic system. When we intentionally link our speech to clear visuals, we strengthen recall dramatically. Actually, experiments show that concrete images are remembered roughly twice as well as abstract words. By lighting up both the verbal and visual systems, you create 2 completely independent memory traces. You're effectively doubling the paths for recall.
Which brings us right to our third section, the zero redundancy rule.
Now we have to be incredibly careful here, because our dual coding strategy, it can easily backfire. Imagine a fish and chip shop worker trying to process a phone order and an online order from the exact same customer at the exact same time, and this brilliantly illustrates the problem. Sending the exact same information through 2 different channels doesn't reinforce the message at all. It just causes confusion and overloads the poor worker, or, in our case, our audience's working memory.
This leads us directly into the multimedia learning traps that you really must avoid. First up is the split attention effect. This happens when you force learners to look back and forth, like trying to match text on one side of a screen with a complex diagram on the other. It's a huge waste of mental bandwidth. Then there's the redundancy effect. This is classic: reading dense text out loud while that exact same text is displayed on the screen. Doing this literally forces your audience's brain to waste valuable time verifying if the spoken and written words match, instead of actually learning the concept.
Let's transition over to Section 4, organizing with Gestalt principles. Let's move to Gestalt shortcuts and see how this builds. These are essentially psychological principles showing how the human eye naturally groups and organizes visual information totally effortlessly. First is proximity. Our brains just automatically group objects that are physically close to each other. Second is similarity. We instantly connect elements that share visual traits like color or shape. And third is closure. Our brains will automatically fill in the missing parts of incomplete shapes. By intentionally using these natural biological shortcuts, you're organizing the information for the viewer, totally saving their brain from doing all the heavy lifting.
We can also use these principles to anchor really complex ideas. You've got to turn hard-to-grasp abstract vocabulary into something concrete. Like, for example, how do you visualize a highly abstract concept like 1 million AI tokens? You definitely don't use a cluttered, messy graphic of a computer chip. You use a simple analogy, like visualizing a massive library bookshelf filling up or a vast pile of grains of sand. As you'll see here, you can anchor ambiguity as a literal fork in a road, or trade-offs as a balanced scale. By using minimalist design principles in these concrete visual anchors, you guarantee clear communication without all that visual noise.
Okay, Section 5, simplifying software architecture.
We can apply these exact classroom psychology concepts to massive real-world tech problems, like documenting incredibly complex software systems. Now, what's really interesting about this slide is how the traditional UML model demands learning 14 highly complex diagram types. I mean, sure, it's comprehensive, but it's incredibly dense. In stark contrast, the C4 model focuses on just 4 practical, totally minimalist levels of abstraction. The C4 model perfectly embodies cognitive load reduction in the tech industry because it ruthlessly strips away everything but the absolute essentials.
Here are those 4 progressive C4 layers: context, container, component, and code. By stepping through these 4 layers just one by one, developers don't get completely overwhelmed. The context layer just shows how the system fits into the world. The container layer shows the major building blocks, and so on. Instead of dropping one massive, terrifying UML diagram that usually just gets ignored anyway, C4 provides exactly the right amount of detail for the audience at that specific moment. It completely prevents cognitive overload.
Finally, let's bring this whole shebang together with Section 6, the active visual critique.
For this final step, I want to put you right in the shoes of a teacher. Your goal is to show students how to reduce cognitive load in their diagrams by actively critiquing a messy, overloaded slide. Look at your own work and ask yourself, what visual noise doesn't belong here? I want you to actively evaluate your own typical presentations right now as we prepare for a pretty ruthless visual takedown.
Okay, imagine a student submits this AI-generated diagram meant to teach the mathematical concept of fractions. It shows 3 apples resting on a highly detailed wooden table, sitting next to a window with bright sunlight pouring in. Sounds pretty, right? But as a teacher, you've got to point out that the table, the window, the sunlight, that is all pure extraneous load. They are just decorative visual noise that heavily distracts from the core concept of the fraction. Honestly, they actively damage learning.
So the crucial point is applying what we call the zero redundancy protocol. Step 1. Identify the core structural knowledge you actually want to teach. In our apple example, just the apples representing the fractions. Step 2. Spot all the decorative elements, the shadows, the little stylistic flourishes. Step 3. Ruthlessly strip the visual back to its absolute pedagogical core. Prioritize zero redundancy rules to strip away literally all non-essential visual distractions. Creating perfectly clean, high-contrast, zero redundancy visuals, that is the ultimate secret to effective communication. Which brings us to a final thought I want to leave you with. What non-essential distraction will you strip away from your next presentation? I highly challenge you to take this explainer to heart, apply the zero redundancy rule to your own slides today, and just watch your ability to explain complex topics absolutely soar. Thanks so much for joining me.